Aloha champions and welcome back. We're starting a new unit in CKSCI. So we've talked about biology, we've talked about geology, we've talked about some physics and the study of waves and energy. We've had a busy year so far in science. Well, now we're in unit 5 of CKSCI, using natural resources for energy. So we're going to explore some new, unique topics. Some of those topics we're going to be exploring through the next nine science videos are understanding what renewable and non-renewable resources are, what type of fossil fuels there are, how we use fossil fuels, nuclear energy, wind energy, hydroelectric energy, solar energy, geothermal energy, and thinking about different ways in which we can innovate with our energy resources. So it's a busy unit all about energy and how we power our world, how that laptop that you're watching, Mr. Chambers, on the video is powered through various forms of energy. So to get us started here on chapter 1, we're going to be talking about renewable and non-renewable resources. So as any time that we look at science, my eyes go immediately to our big question. Our big question for chapter 1 of unit 5 is, what is the difference between renewable and non-renewable resources? Okay? So renewable and non-renewable. We want to know what's the difference between these two different types of resources. Okay? Well, our renewable resources are resources that can be restored more quickly than it is used up. Non-renewable resources are resources that cannot be restored as quickly as it is used. So if we use it faster than we can make it, then it is non-renewable. But if it generates faster than we can use it, it's a renewable resource. But there's a lot more information provided here in this chapter to help us understand the difference between renewable and non-renewable resources. Okay, so without further ado, let's get started into chapter 1. 3 hikers prepare dinner at a campsite. One boils pasta over the blue flame of a propane gas stove. Another fries fish over a wood fire. A third roasts vegetables in a solar oven over the course of the afternoon. The wood and solar energy used for cooking are known as renewable resources. They will not be used up completely. While neither resource is available everywhere or all the time, both are renewable. The sun comes up every day, and trees can continually be planted and harvested. The propane in the camping stove is a non-renewable resource. It takes much longer than a human lifetime for propane and other fossil fuels to form. Okay, so here we have our camper. He's got his propane stove. Propane is abundant now. We have plenty of it. But once the natural gas that is used to make propane is all used up, more won't form fast enough for it to be used as an energy resource. So when we're thinking about energy, we want to think about what types of energy sources can we reuse or renew before we need it again. Okay? So page 2, availability of energy resources varies. It depends on where you are and what you're doing on how much energy you have. Our vocabulary term here in the box is a fossil fuel. A fossil fuel is a fuel formed from the fossilized remains of organisms, whether it's plants or animals. If they've been fossilized and compressed under layers of rock, they will form a fossil fuel. Natural gas is abundant. So is petroleum and coal. to other types of fossil fuels. Abundant does not mean renewable. However, what makes a resource renewable or non-renewable is how quickly it is used compared to how long it takes to become available. Fossil fuels develop over thousands of millions of years. Humans have been extracting fossil fuels from Earth's crust for centuries now, but the rate at which we use them is much faster than the rate at which they form. That is why they are non-renewable, even though there are plentiful right now. A resource can be renewable, but not necessarily abundant. For example, some locations do not get enough wind to generate electricity reliable for people's needs, and even sunlight can be too scarce to serve as a dependable energy source in some locations. So wind farms and solar farms, those are very dependent locations for renewable resources. Here in Arizona, we're a prime candidate for solar but not so much wind. Up in the Arctic Circle in Alaska, probably not a good candidate for solar energy because during their winter months, they have some days where they don't see any sunlight at all, depending on how far north they go, up until the North Pole, where you can have up to 60 days with no sunlight. Okay. Some energy resources are renewable. And this brings me to my vocabulary term. Electricity is a form of energy resulting from the flow of charged particles. We talked a little bit about electricity earlier on in the school year when we talked about energy and how that moves. Well, electricity is something that we use renewable and non-renewable resources to help form, and they run that very computer you're watching this video on now. Renewable resources that are used for energy include wood, wind, flowing water, sunlight, and heat from Earth's interior. In some cases, these energy resources are used in their original forms to apply energy or force to something. For example, sails on a sailboat harness wind to push the boat across the water. In other cases, the energy is transformed to a new form. A windmill, for example, converts the energy of moving air to a mechanical energy that turns gears into machinery. These days, most energy resources are converted to electricity, whether it's a windmill with the turbine inside, or we've got a water mill here that used to churn flour. Now we have hydroelectric dams that have fast-spinning turbines that power entire cities. However, renewable resources can still be costly. Just because we can renew it doesn't mean that it's the cheapest option. The use of renewables is not necessarily problem-free. For example, large wind turbines built to harness wind power can pose hazards to birds as well as aircraft. Renewable energy can also be very expensive. A homeowner who wants to turn his or her roof into a solar power generator may have to spend thousands of dollars to install solar panels. Yes, there are grants that you can get if your family is considering solar, but it is not the cheapest route to start off. Tapping renewable energy resources can also be harmful to landscapes, rivers, and other habitats. The dams that provide hydroelectric power in some locations may damage the environment around them. A dam may block fish, such as salmon, from traveling upstream to reproduce. The construction of a dam usually involves flooding a large area of land. I wish I could match in. There's this device where there's fish farmers who help salmon go and shoot them up a pipe up to the other side of the dam so they continue their migration paths. Technology is beautiful, but there are problems with renewable energy. With any kind of energy, you've got your pros and your cons, the good and the bad of what makes this so. And throughout this whole unit, we'll talk about some of those good things and some of those not so good things about different energy resources. Okay? Petroleum is a non-renewable resource. And our vocabulary here is crude oil is a liquid also known as petroleum. If your parents drive a car and it's not an electric, chances are it runs on a form of petroleum or petrol that powers as gas for your vehicle. So, crude oil, also known as petroleum, is a liquid formed over time by fossil remains that are under intense pressure. Petroleum is refined into many liquid fuels, including gasoline for your cars, diesel for the big trucks, and kerosene if you go camping and have a lantern. Petroleum is also made into plastics, lip balm, and a lot of other products. Petroleum is taken from Earth's crust by drilling holes deep into rock. A large underground field of petroleum may be under enough pressure to force the petroleum out of the crust and up through a pipe. Petroleum can also be pumped from the ground. The hole through which the petroleum is taken is called a well. If a well is not controlled, it can blow out, causing an oil spill. Oil spills are dangerous to humans working on or near the oil well. They can also be very harmful to wildlife and ecosystems. These are some of the costs associated with using petroleum. Petroleum can be transported by pipelines, trains, trucks, ships, and other forms of transportation. It is processed at a refinery, a place where crude oil can be changed into very many different useful products. These are the benefits of using petroleum. So usually it's an offshore oil rig that digs deep down, and you ship the oil from the oil rig to the refinery to turn it into many different things that we have in our day-to-day lives. Okay? Natural gas and coal are also non-renewable resources. We can't make them back as fast as we use them. Natural gas is another fossil fuel. It often forms in the same type of location as petroleum, from similar remains of organisms. Like crude oil, gas can be extracted from Earth's crust and transported to other places. And like crude oil, or petroleum, it must be refined before it can be used. Natural gas is used in many homes for cooking and heating. This requires a network of pipes to bring the gas to homes. Because gas is under pressure and flammable, accidents such as explosions can occur. Coal is the third major type of fossil fuel, but unlike gas and petroleum, coal is a solid, not a liquid. It forms mainly from the fossil remains of plants that once lived in a very wet habitat. Coal has been abundant and inexpensive for centuries, but mining it is very dangerous. When coal is burned, it produces a lot of carbon dioxide and releases other pollutants into the atmosphere. These fossil fuels are usually burned to transform chemical energy into thermal energy, heat. The transformation can cause the parts of a car engine to move or heat water inside an electric generator. So here he is holding a piece of coal taken from a mine. But using coal has costs and benefits. Its pros and its cons, just like everything else. Many power plants that supply electricity are powered by coal. In them, coal is burned below a large container of water called a boiler. Burning coal heats the water, which boils and forms steam. Because the boiler is sealed, the steam builds up, and as that steam expands, it moves through pipes to an area of lower pressure. Here, the moving steam spins turbines. These turbines convert the energy of the stream into mechanical energy that moves a generator. This converts the energy of motion into electricity, turning that kinetic energy from the moving steam through the pipes, spinning the turbines, and that spinning turbine is connected to gears, which powers up and delivers electricity. The sooty gas produced by a burning coal can be treated to reduce some of the pollution. In some locations, the carbon dioxide is directed underground. In general, however, most of the carbon pollution goes up into the atmosphere. Air pollution from coal-fired power plants can also contain mercury, which can then end up in the water, and it accumulates in organisms that humans eat, such as tuna or many other fish. These are some of the costs of using coal. Okay, so here's an example. If we dig up the coal, we burn it in here, it goes through all these pipes, spins the turbines, some carbon dioxide goes off, and some go back into the river and pollute our fish. Okay, last type of energy we're talking about for today, and we will go into much more detail with all of these throughout this unit, is nuclear power is a non-renewable resource. Another type of non-renewable energy people use to produce electricity is nuclear energy. Nuclear energy has been used to make weapons, but it has also been used in nuclear power plants. In a nuclear power plant, the release of energy is controlled. Controlling the energy release allows heat to be directed into a boiler similar to what is used in coal power plants. The boiler produces steam that spins a turbine, which makes a generator produce electricity. So regardless of whether I'm using coal, I'm burning oil, or nuclear energy, it's always spinning a turbine through the gases that it creates. Nuclear power does not release carbon dioxide into the environment, but it still has its costs. If the release of energy is not controlled, the reactor can generate too much heat and melt part of the reactor. This exposes the surrounding area to radiation. Radioactivity is the release of harmful particles from a substance. Radioactivity can be deadly to organisms. It can also linger in an environment and cause a variety of diseases over a very long time. Okay? So here's a picture of an incident of Chernobyl, which was a nuclear power plant that had a faulty reactor, and the whole city within 30 miles became too irradiated to live there. Okay, but we'll get into all of these different types of energy, renewable and non-renewable, and learn the difference between them. Now that you've watched this video, you have 5 to 10 questions to answer on Google Classroom about what you learned from this video. So thank you for watching, stay awesome, and I will talk to you real soon.